We're going to look at some absolute value inequalities. So inequalities that rely on absolute values, and we've got some various results, some of these results given in textbooks, and we're just going to explain a few of them by our example largely, because that works really well for this stuff. First one there says if A is some number, okay, and so if A is at least 0, then the absolute value of x is less than or equal to a, which is equivalent to negative a is less than or equal to x, which is less than or equal to a. Now that might be a little bit hard to comprehend on its own. So let's look at an example. So let's say, by example, let's say a is 2. So a equals 2, and we've got, then we'd have the absolute value of x is what we've got to consider next. So we've got less than or equal to is less than or equal to 2. So x is less than or equal to 2 is the second statement there. If we did substitute 2 in, and we got to show that that's equivalent to negative 2 is less than or equal to x, which is less than or equal to positive 2. And so we can use a one-dimensional graph or a number line and just quickly sketch that there and show that. So just put in a few spots there in this one-dimensional graph, and we've got 2 there, negative 2 there, and we'll put the arrows on the end there. And so we're going to show that the absolute value of x is less than or equal to 2. Well, is it the same as that? Because if we look at that, we know how to plot that interval on a graph, don't we? So that would be such with the light green from there through to there, and all real numbers in between. Do we get that by looking at this? Well, let's work on that based on some of our previous work. So if we've got the absolute value of x is less than or equal to 2, that means we've got two values. It could be a case where the easy case is that positive x is less than or equal to 2, and there's another case where the negative of x is less than or equal to 2. Now when we multiply an inequality by a negative, we multiply both sides as if they were an equation, and we change the direction of the inequality around. So we have basically x is greater than or equal to negative 2 and x is less than or equal to 2. And look, again, that is the same as what we've got, because this one here means that, I'll just put it straight on the top, it would be solid. You should be plotting these on the number line, but I don't want to go over the top of other things. And down to x is greater than or equal to 2, so that would be limited by that, and everything in between. So it is the same region, so yes, they're equivalent to. The same thing would work if we had things like those inequalities as well. It works the same, except for those two that I just wrote, you'd have open endpoints there on the one-dimensional graph on the number line. An example would be absolute value of x is greater than 5. So again, we look at the two possible ways that could be. We could have negative x is greater than 5, or positive x is greater than 5. So we have this result and that result there. Now for this one, negative x is greater than 5. We multiply both sides by negative 1, so positive x and negative 5, and we switch the inequality around. So x is less than negative 5, and this one is self-evident, x is greater than 5. And so on a number line, we would have, we've got 5 there, and negative 5 there. Alright, we would have basically x is greater than 5, so we've got 5, that's an open interval, and it's everything out to infinity there. And x is less than negative 5 is open there, and it's there like that. So voila. Likewise, this one here might appear to be quite tricky to understand unless we use an example. So I'm just going to use an example of 1. So the absolute value of x minus k is less than or equal to a. what if we have the values here? And I've just used 1 and 3 respectively for k and a, and we have two possible values there. So we have the positive and the negative. So the positive's easy, we just have x minus 1 is less than or equal to 3, add 1 to both sides, and x is less than or equal to 4. On the other side we've got the negative option, and that would be less than or equal to negative 3. So times both sides by negative 1. So we would have negative 3 now, and we've got to reverse the sign of the direction of the inequality sign, and now we add 1 to both sides, solving it just like it's an equation. Okay, and we've got our answer negative 2. And that does actually match, because we had this statement at the end. If you want to check the veracity of that out, we said k equals 1, so we have 1 minus, and we said a is 3. Okay, so that's negative 2, which is less than or equal to x, and we have k plus a there, and that would be 1 plus 3, which is 4. Alright, so 1 plus 3, which is 4, and look, that matches there what we got there. Okay, x is basically greater than or equal to negative 2, which means negative 2 is less than or equal to x, and x is less than or equal to 4. And if you look, that matches that right there.